So 2.3, here's thoughts on 2.3. Okay, we have a picture, we have to do the domain. We just have to tell what the domain and the range are, and then we'll talk about intervals on which this is decreasing and increasing. So real quick, my take on this one is domain of such a thing. Remember, quadratics, they keep on going forever. Not only does this keep going down, but it keeps on going out, as you can see. It's not quite straight down. It's not like it's going straight down. So it also has an outness to it. And so even though the slope is decreasing a little or increasing over time, it keeps on going diagonal down. So if we're talking domain, it goes forever to the left and forever to the right. And we're looking at just infinity to infinity for the domain. So the domain, they have a funny way of doing it, but it's essentially you just click buttons until it looks like we're saying minus infinity to positive infinity, because that's the way these quadratics go. The range is a little different. That one's going from, the range is the y values, remember, so we'll say that's going from downstairs. It's like a function that's coming from way down here, and then it hits up top, and then it starts going down again. So from way down here is, of course, that's infinity negative is where we're coming from. So we're going from, as far as range goes, the y values that work for this one, it's from infinity negative all the way up to 1, it looks like. And that's it, because then it starts going back down again. So the range, the y values that we get on this character are from negative infinity all the way up to 1, and it looks like we hit that 1, so we'll go ahead and bracket it. Okay, what else? Sorry for the wiggle camera. I'll try and stop bouncing that around. Now we're looking for on what interval is this thing increasing, and so remember when they're asking you for the interval on which it's increasing, they're talking about parts of the domain. It's an x value thing. So they're just looking at this function. It looks like it's going uphill for a while until it hits right there, and then the other half of it's going downhill. So we'll say on this side over here, everything to the left of that, whatever's it, -1 line, everything on the left-hand side, looks like that's where it's increasing. Then it's decreasing over there. So we'll just describe that in terms of the x values here, of the function inputs that make this thing keep on going up. And so, let's see here, that means everything on the left-hand side, so that's from negative infinity way over here, all the way until we get to, I guess, -1 is the split line right there, because that's where it starts going down again. So we'll say this thing is increasing from negative infinity on the left, all the way until we hit -1 on the right. Only thing interesting to mention about that is, again, like we had probably mentioned in class, we'll see, if we're going up to the top here, that -1 point, this point right here, seems like it's not increasing anymore, but it's not decreasing either. It's just a flat point. So for that reason, it seems like we won't include the -1 in the increasing interval. And so something like, I guess we'll do parentheses there. Okay, what else? So there's more like that. Then there's some graphing. So like number 3. We have a transformation and a bit of a stretch, so you might remember -2 means down 2, and then we have a -1 plus 1 is our new 0. So -1 plus 1 makes 0, so -1, and then all that stuff, and it zeroes out, and then -2 means down 2, so it'll be -1 and then down 2. Boom. There's our turning point, or our vertex. And then remember that if we have a times 3, that's going to scale this thing. It'll dilate it, or whatever we call it. And so it stretches it. And so instead of going over 1 step to either side, and then we'll go up 1, in this case, if we go over 1 step to each side, it's actually up 3 times as much as that, or up 3, whatever number it says there. And so in this case, 3, so we're up 3, and then I'll go 1 to the left, and I'm up 3. And so then we're at there, and then you just kind of connect the dots. That's pretty good. If we need more detail than that, we will, but that's good enough for now. That's 3 dots to make a parabola. Okay, what else? Wanted to mention this one too, because it has that minus in front. Not much different though. So the 0 here, the new 0 would be +1, and then it's down 3. So we'll go to +1, and then it's down 3. 1, 2, 3. There's our vertex, and then we'll say -3 is going to tell me, okay, if I step 1 step in either direction, oops, I'm not in the drawing. Sorry, -1 down 3. -1. Okay, so if we did 1 step in each direction, this time we're going down 3 steps is all. 1, 2, 3. And then 1 step to the left, down 1, 2, 3. Because it was times by a -3, so it's an upside downy Looking good. What else? Let's see here. There's different variations on this stuff. Here's something interesting. On number 7, we're not given vertex form. It's one of these in standard form, whatever we call it. And so you might remember what we did in class. We're going to handle this by, we'll keep the 14 and we'll look for matching dots in that way. So let's see. If we started out by seeing like x and y, we have, if I plug in a 0, that's easy enough. Plugging in a 0 will be 0 plus 14, because 0 squared and stuff, you know. So 0 gives us out a 14, and then we're going to look for another matching dot that will also give me a 14 out. So we'll be like, well, is there some other thing, a new 0, that will also give me a 14 out? And so to dress that up, normally we'll fix the function and be like, well, I'll keep the plus 14 at the end, but this part I'm going to start looking for a new 0. So if I underline those two, we'll take out whatever they have in common, maybe factor it out. Let's say they got both an x, so if they take out an x from both, then there's x plus 8 left over. And now that that part is in, there we go, in factored form, now I can see my new 0. Old 0 was at 0, so I could plug in 0 there and get it. But also new 0, if I do negative 8 here, negative 8 plus 8 makes this into a 0. And when I times it by whatever, I'll still get 0 plus 14. So new 0 is negative 8, which will also give me 14 out. And that's good for us, because now I got two different x values, got the same y value, and now I can find matching dots, and it'll help us to start drawing the picture. Let's see. So if we got 0, 14, that's way up here, off the graph. 0, 14, I'm just going to draw way up there. 0, 14, and then what's the other one? Negative 8, 14, that means we're going to go, let's see here, negative 8 is way over here, and then that's up to 14. Looking good. And then from there, guys, we're going to have to try to figure out where the vertex is. But remember, if this is at 0, and that's over 8 steps, right? Negative 8, halfway to negative 8 is where our vertex will be, is halfway between these things. So if it's halfway between, we'll just draw a little line at halfway to that 8, which is negative 4. We got ourselves a halfway line. And then we'll say that's exactly how far over the vertex is going to be. What that tells us, if you'll remember, is I'm going to put a V for vertex here. That means the vertex, we know the x value already is negative 4, because that's how far over it is. It's the x value. Now I'll just do some algebra to figure out the y value. So we'll go back to the old function. In whatever form you want to work with it, I'm going to go back into the original, and we'll shoot in negative 4 in for those x's. Let's see what that looks like. That's negative 4 being squared plus 8 times negative 4 plus 14. And then we're just running numbers. This is 16, and that's a negative 32 plus 14. 16 minus 32 is negative 16. It goes that way. You know, this will always be like twice as big as that. If you do it this way, it's weird that like that. Anyway, negative 16 plus 14 is negative 2. And so it looks like we got ourselves a vertex here. Negative 4, negative 2. Shakalaka. So we got ourselves a vertex at negative 4, negative 2. What that means for us on the picture is we knew it was negative 4 already. We already knew how far over it was because it was between those dots. So it was negative 4, but now we know how far down it is. It's at negative 2. And now we can just connect those dots. Look at that. Whoosh. Whoosh. Boom. If you're using the graphing tool in Canvas or MyOpenMath, and it doesn't let you put dots way up here, what you could do is just kind of draw it by hand at first, and you'll know to use these to get your vertex. And then if you need a couple more dots that, might work better or something, you could always say, well, now that I know negative 4 is here, I could always try plugging in negative 5 or negative 6 and, stuff like that. So I can get other dots that might actually fit on the graph. But hopefully they'll let you expand it out so you can put dots where you need to. Okay, what else? Ones like that. Here's an interesting one. We have 2t squared minus 8t plus 6. Similar idea. It's got a number here. What some people do is maybe they'll even take a 2 out of everything. You could sort of make that work. I don't know. It makes it tougher when you're graphing it. It's hard to visualize what that would do. Maybe that'd be worth looking into. But Well, I guess you could do it by finding intercepts or something. Whatever, there's a lot of ways to do this. If we stick with what we've been doing, we could be like, well, x and y. I'll plug in old 0. 0 will give me 0 minus 0 plus 6, so I get a 6 out of it, and then I'll look for another way to get a 6 out of it. And so we'll say I'll preserve that 6, and I'll hope to make this into a new 0 plus 6. These guys, I'm looking for what they both got. So I could be like, well, they both got a 2 and a t, so I could take out a 2 and a t, and then I'd have t minus 4, yeah, plus 6, and then that'll be enough to tell me that over yonder, we have a positive 4, take away 4 is the new 0. So if I put in a 4, that will also give me 6. So now we got those two dots we can work with. So 06 and 46, 06 and 46. And then right between the two of them, we'll find our line of symmetry, our axis of symmetry. And that'll tell us where the vertex will be hiding. So if we're shooting for the vertex, that's halfway between the two of them, and that's going to be at 2 steps over. So we say the x value is at positive 2, and we'll figure out the y value by algebra. So then, let's see, if we put in a 2 into the function, what's that going to look like? 2 into the function would be 2 times 2 squared minus 8 times 2, and then plus 6. Let's see what that does. 2 squared is like 4. 4 times 2 is 8. This would be 8 take away 16. See how it's always twice as big? Plus 6. 8 minus 16 is negative 8. And then plus 6. So we got negative 8 plus 6 would be like negative 2, I guess. And now we got ourselves a y value, which is the same one as that we had before. So we got negative 2. And so our vertex will show up exactly there. It's at 2 steps over. We already knew that. It was an x value of positive 2 anyway. And now we know how far down it goes. It goes down to negative 2. Oop, negative 2. Don't tell anybody about that. Scribble. Negative 2. And we'll just connect the dots. Looking good. Beautiful. Almost hit them. Cool. Other issues you might run into. Sometimes, let's see here. Pause. And unpause. I was thinking about something. Yes, dig this. Number 12, there's different ways of handling this. Normally we complete the square to make this thing work, but we haven't reviewed that in this course yet, so I was going to take you through a cheater's way for now. And so we have to put the equation, this mess, into the form of like x minus, whatever, it's the h and k thing. It means to put it in the form of like we used to look at them before, like in problem number 4. Remember when we did this one? And it told us just, when you have it in a quadratic in this form, it tells you exactly how far down to go and where the new 0 is. It tells you where the vertex is. So you don't have to do any of this funny equation bit that we've been doing, and you just kind of draw them. And so, I call it vertex form because of that. But for right now, it's mystifying to know how to turn this kind of an equation into that kind, so that we can find the vertex easier. So what I'd recommend for now is we're just going to find the vertex, and then that'll tell us how to write that one, since we know how to kind of find the vertex with these things. So check this out. We'll pretend like we're drawing it. Let's see here, x squared plus 20x plus 91. So we could say, well, if nothing else, I'll start out the old x and y chart. I'll plug in a 0, and a 0 will give me 91 out like it does. It's kind of an up 91 thing. And then I'll plug in a new 0 to get me a 91 as well, just like we always do. And so a new 0, let's see here. If I took out the x from both of these things, then x plus 20 plus 91 is left. And that means new 0 is negative 20. So negative 20 will also give me a 91. And then it's time for the vertex. So let's see here, 0 and 20, halfway between 0 and 20 is negative 10. So halfway to that 20 is negative 10. And then we'll just shoot negative 10 in. And this is us doing it without drawing it, but feel free to draw it as you go. If you want to go just make a rough draft of 0, 91 would be way up there. Negative 20, 91 would be way up there. And then you can kind of remind yourself visually that the axis of symmetry will tell us where to cut this thing. It's halfway to the 20, and so that's where your negative 10 is. And then we'll plug in negative 10, see how that goes. Let's see, negative 10 squared plus 20 times negative 10 again, plus 91. What's that going to be? The negative 10 squared, what's that, 100, plus like a negative 200, so minus 200 in cursive, plus 91. And then 100 minus 200 is like negative 100, I guess, so negative 100 plus 91 is like negative 9, I think. So assuming I didn't mess those numbers up, negative 9 looks about right. We'll say, oh, that's negative 9. And now I just have to say, now that I have this vertex, can I put this equation in what we call vertex form with the new 0 showing and the up and down number? And I think that we can. We'll say this is y equals, and we'll figure out the whole squared thing. So I'll put x, and it'll be plus or minus something. But the easiest part is the plus k. Remember, that's your up and down number, and that's negative 9. So we'll just put minus 9. Ta-da! And then remember about new 0, it's always kind of opposite of what you think. So this 0 is at negative 10. So if I have to do a negative 10, then I'm going to put x plus 10. It's always the opposite of what it looks like on the inside, right? I'm going to put x plus 10 so that negative 10 plus 10 makes 0. So kind of opposite of what you figure it's going to be. There's no number scaling out the number in front of the x squared, so there won't be a number in front of us here. So we're looking at just y equals x plus 10 squared minus 9. Some other ones. Let's see here. 14, we have to find the, what is it? Oh, just the vertex and all this stuff to do with this function. And so maybe we'll handle it like we've been doing, but just a little bit more fast forward technique. And it's a little bit ugly because it has a 3, an odd number. So that'll be a little bit funky. So let's see how that goes. If we have x and y chart, I plug in a 0 and I get a negative 18 out. Then we do that thing with these two, and we'll take out the x, and it's x minus 3 minus 18. So new 0 is positive 3. Positive 3 also gives me a negative 18. Now I can find my vertex, but it's good to get a rough draft of the picture as you're going too, because that'll help us with some of the other stuff. Although I don't see it asking for the axis of symmetry at this point. I kind of expected it to. We'll just go ahead and give it to them because I think that they'll ask for that on other problems. It looks like later problems they ask for that. Anyway, so here comes the vertex. It's halfway to the 3. You can do that by just taking the 3 and dividing it by 2. If you would prefer, you can do 1.5. That's fine. Although some decimals don't go well. If you had, again, if we had like 2/3, that doesn't do well as a decimal, so then you got to go fractions. But either way, just take this number and divide it by 2 should work. Now we got 3/2 or 1.5. We're going to shoot into the function and get a vertex. I'm going to go ahead and painstakingly go through it in fraction land because sometimes you just got it because the negatives or the decimals don't always work out. So x squared, that'll be 3/2 squared minus 3 times 3/2 minus 18. And yes, this will be twice as much as that probably. It's whatever. I mean, you can kind of see that it is, but whatever. Anyway, so 3/2 squared would be 9 over 4 because it's 3 over 2 times another 3 over 2. So that'll be 9 over 4. And then, let's see here, 3 over 1 times 3 over 2. That's just minus 9/2, which is twice as big as 9/4, minus 18. And then we'll just get all the bottoms to match and then shoot it in there. Let's see here. If we made them all over 4, this would be 9/4 minus 18/4. 9 over 4 minus 18 over 4. And then this is 18 over 1 right now. So 8 times 4 times 4. Whatever the heck 18 times 4 is. 72 or something over 4. Let's assume. We'll just hope that I didn't mess those numbers up. And then 9 minus 18 is negative 9. Negative 9, take away 72 would be a big negative, like negative 81. Yeah, dang it, negative 81/4. And that's a horrible looking number, but whatever, it's our vertex. So if we want to know how to draw it, we will. Otherwise, we'll say I got the vertex, it's 3 over 2, and it's negative 81 over 4. The axis of symmetry is worth mentioning, because we'll have to do that on other problems. Anyway, so if we keep our drawing going, 0, 18, we know where that is. 0, negative 18, somewhere down here. Negative 3, oh no, it's positive 3, negative 18. And then we know that halfway between those two was the vertex, which we knew was halfway to 3, and that's 1.5. And so blah, blah, already did the vertex. But if they ask you for the line of symmetry or the axis of symmetry, it's this line. And so all we say about that is that's just x equals 3/2, or x equals 1.5. Just don't forget the x equals part because it describes the line. And then, let's see here. So that's easy enough. So that's the, what do we call that? The symmetry line, axis of symmetry. It's our little symmetry line. And then we have also, sometimes I ask you for the x-intercept and the y-intercept. They just want one of the x-intercepts this time, it's whatever. The y-intercept is super easy because that's always the first dot we ever find. The y-intercept is where we hit the y-axis, and that's when you plug in 0. So it's just, 0, 18. It's that first dot that we ever found. When you plug in a 0, you get yourself to minus 18. Remember what that does is it puts us right on the y-axis at 18 steps down. That's our y-intercept where we hit the y-axis. So we'll say y-intercept, already found that, 0, negative 18. And then they want to know, what is the largest x-intercept? Well, we're going to have to find both of them to be able to tell which one the largest one is. So let's see here. And there's always a chance, by the way, it doesn't specify here. So if you're in Canvas and it doesn't take this, sometimes they just want to have just the 18 part, So try that if they don't take it in coordinate form. And then x-intercepts, what we'll remember about them is that the y part is 0 there. Hopefully we've talked about that in class by now. And so the y part is 0 there. And so we're just going to handle this by shooting a 0 in where the y would be, or the f of x in this case, and see how that goes. I'm going to do that on a different sheet real quick. Let's see here. If we got this thing, if I plug in a 0 where the y goes, let's see here, x squared minus 3x. Okay. So if we put a 0 where the f of x is, that's x squared minus 3x minus 18 equals 0, essentially. And then we'll solve it any old way that we can. Since we haven't reviewed quadratic formula or complete the square again, we'll just, hey, sorry about the wiggle camera, we'll handle this by factoring because it goes well, I think. Let's see here. I'm thinking x minus 6 and plus 3 will add up to that negative 3. And that means that something minus 6 equals 0.